Simulations and Verification of Wireless Technologies, a joint project between vehicle OEMs, subject matter experts, and academia. The project focus has been on cellular connectivity, vehicle-to-vehicle communication, and vehicle-to-infrastructure communication. The aim of the project is to be able to verify antennas and telematic units earlier in vehicle projects through simulations and different test setups. We have divided the project into 3 parts. First, we have the simulation framework, which focus on 3D channel models, communication stack, and the antenna radiation patterns. Then, we have non-functional testing, which means lower layer testing, with parameters such as power levels and the antenna characteristics. And lastly, we have the end-to-end testing of vehicle applications. In V2N communication, the quality of service can vary depending on the network configuration, whether it's standalone 5G or non-standalone. In our tests, we measure key parameters like throughput and signal quality across different frequency bands and network configurations. These tests matter because vehicles today rely on connectivity for everything from navigation and infotainment to advanced driver assistance systems. A dropped connection during poor coverage could mean delayed safety alerts or interrupted communication with infrastructure. By systematically testing these scenarios, we can better understand when and why performance drops and design for resilience across real-world use cases. When testing vehicle connectivity in real-world environments, results can vary dramatically due to changing network loads, unpredictable interference, and even weather. To get consistent, comparable results, we need a controlled setting. That's why we use controlled test environments, where we have solutions like a reverberation chamber or using RanLOS test system. Looking at the RanLOS solution, a compact and flexible over-the-air test system for evaluating vehicular antennas in a controlled setting during development. It simulates real-world conditions in a consistent, realistic, and repeatable environment. The setup enables precise measurement of directional properties such as antenna radiation patterns, which are vital for generating consistent and comparable results, especially under dynamic conditions that are difficult to reproduce in field testing. This type of testing is essential for understanding how things like antenna placement and vehicle design affect vehicle connectivity performance. It helps improve the reliability of the wireless system earlier in the development process. A reverberation chamber is an environment where we can recreate a wide range of realistic radio conditions, but with full repeatability. It allows us to isolate variables, test edge cases, and evaluate system behavior with precision. A reverberation chamber is essentially a large, shielded room that reflects radio signals off its walls to create a diffuse, multipath-rich environment, much like what you'd find in urban canyons or inside buildings. By moving mechanical stirrers, we simulate realistic signal dynamics in a statistically uniform way. This makes it possible to test wireless performance under harsh and complex radio conditions that are difficult to reproduce outside in a repeatable way. Once we've run our tests, we analyze the results to understand system limitations and opportunities. We're looking at metrics like throughput, sensitivity, error rates, under controlled, repeatable conditions. These insights are critical to improve robustness, optimize installations, antennas, and ultimately ensure reliable V2N connectivity in real-world conditions. If you are interested in knowing more, please visit the Vinnova webpage to read the report.